Hello, everybody. It's Hamish here from very, very sunny California. So, yeah, I'm currently sitting outside. So, if you see, sorry, rather, if you hear any wind noise, then my apologies, but hopefully you should get the general gist of what I'm trying to do. So, basically, I just want to show you a few different things, um, specifically just live code, a few bits of the general feedback I was trying to give to you guys today. Um, that sort of came through about your works. Just kind of wanting to go over some of the things, but do it in a slightly more thorough way with a bit of live coding. So I'm going to use Sebastian Hank. I'm pretty sorry if I pronounced it wrong. Hanekom's work. So I think I know it's well. Sorry, Sebastian. Little quick tip for if you're a Mac user. If you do control, so control and then click. That's obviously a right click. But now, whilst it's up, so I'm not holding anything, I'm not pressing anything down at the moment. If I press the Option key, then you see how like you get the alternative menu. So I usually do that and then just go copy as path name, and then I'll go into my terminal window and type in Jupyter Notebook and then Command V, and that's where we at. So, why did I want to show Sebastian's work? That's a good question. So really, I think it was so Sebastian's work. We were used as an example of what's it called? Like just really good formatting in the Markdown. Um, So Markdown mode's really easy to get into. I think, some people or most of the class knew how to get into Markdown mode. Some I think were struggling a little bit, or were commenting cells like this. Just so let's say this was a comment here. A comment. Let's just take out this. This is a comment about this stuff. Then they would just sort of put like a hashtag here, and that's fine. But it's not really. Well, I'll tell you what the main problem is if we keep going, let's just keep going. So let's say you write a really long line of text, which people did. When it's time for me to go mark it, I start off with this is a code. Oh my god, this is really goddamn difficult to read. So if you could avoid doing that and do it in Markdown. So what is Markdown? Well, to access Markdown, let's just create a new cell again. 1 second. So yeah, let's just assume this one here is a new cell, and we're going to put some comment in here. So this is a comment about this cell. Okay, now if you run it normally as a code cell, comes up with this is wrong. But now if we change it to Markdown, there's two ways of doing it. Either you click the side of the cell here, turns a little bit blue, and then this menu here you can click Markdown, or you can go just press M, and if you press M, then it turns it into Markdown. So what we really liked about Sebastian stuff is this kind of work. What do HK, where is it? Where was I? There we go. So here's the question that I asked. What do HK, VK, and IPAC stand for? Answer in a Markdown cell below. And the answer was, well, this is what he's doing. HK stands for hydraulic conductivity, IPAC stands for this, and there's some really nice sort of formatting. So we've got bold, we've got some metallic, I think, possibly in there, and we've got some change of colors, and you can see some more colors and more bits of bold. So if we look at what I wrote, so this again is another Markdown cell. So let's look at the anatomy of Markdown cells. So we've got two hashtags. So layer property flow package, and then we've got some hyperlink. And so this is how you change the font for a section. So if you want a section to be red or you want it to be blue, then you do font color equals red. In this, so this is just HTML language, and then again, it's then closed off by another bit of code which tells it. So in this case, it's font color equals red, then boop, the thing you want red, and then closed by a bit of font. So here, so in order to make it bold, he's put two asterisks, which apparently make something bold. So it doesn't make it a what's it called? Doesn't make it a title, but it just makes it bold. So it's still the same font size as the rest of it. So we've got answer, HK stands for so blue, and he finishes with well, okay. So the person hasn't done closed it out with some font. What is it? Something like that. Eesh. It's like how do you finish it? Yeah, you should kind of really it's good practice to, if you're finishing it, to end it with where it starts and where it stops, the blue font. Obviously doesn't matter if it's the end of the line, but yeah, it's good practice. So yeah, so this is a really nicely formatted code, and even if you know, they've had a bit of problems with some aspects of it, generally speaking, you know, laying it out like this makes my life a lot easier at the end of the day when I come to mark this work. So yeah, please, you know, you don't have to go to this degree where you're introducing blue fonts and black answers, but just doing it in Markdown at the very, very minimum, even if you just keep it the default text, just writing your answers in Markdown makes my life a lot easier. And yeah, when you come to then, you know, obviously you're all doing this fine. When you come to then comment on it on the line, then that's fine and really useful, so I can see it next to the code. But yeah, this style, if you're asking for Markdown answers, would be good. So what was the next thing I wanted to talk to you about? Clean, practical one, teacher marking. Let's try that. So yeah, interested in that. And then where's my terminal window? Jupyter, no. Oh, okay. So I think the next thing I wanted to discuss was to do with. Oh, 1 second. Is this gonna work? Nope. Let's do that. Okay. So let me just check it runs all this file. Okay, so this is so say you get into a new workbook and you just want to check that it all runs, then yeah, you can just go cell run all, and yeah, it failed. So MF 2005. So I've got a new laptop, so I just need to check. So yeah, again, copy as path name, quite a useful function if you're on a Mac, and let's just put that in here. It should run all. Okay, so there it's working. So what was I going to show you? So really, like, this is the bread and butter of what I wanted to discuss. And it was kind of looking at stuff like, say you get a new code, how would you go around breaking it up, breaking it down, working out what's going on? Some people you could tell were doing this, and then other people you could kind of tell were, you know, they would just go, I'm being asked to comment on this, let's just copy this, and let's just Google that, and then let's go here, and then let's just copy this, and that'll do. And that's not really like understanding the code. That's just doing what the instructor kind of told you to do. Really what I'm looking for is, or what I want to see is just in your own words, a bit of an understanding about what's going on. So for example, here, this get underscore node underscore coordinates. Now, let's say I see this for the first time as a bit of code and I don't understand it. Then maybe, yeah, I'll do help. It's a good start. Let's copy that function in there. Okay. No, that's not how you do that. Let's try that. Oh, wait. Okay. So it's saying help on method. Oh, yeah, so you could probably just do... No, that's probably the way to do it. Or can you do it that way? Nah, you gotta do it with this. So this is an object that I think I've just defined up here. So this is the object that we've created. Now, all objects, if you've made an object, then yeah, it can have some parameters around it, but it's still got a load of functions. So I can still see what those functions are that I can apply to the object. So get X, Y, and Z cell centroids. Now, it's one of these things that I think I've seen someone like has done that and then they just copied that answer. Or so what I want you to kind of understand, or when I'm asking for like a comment on it, is not just get the cell centroids, is what does this actually mean? And so in this case, this is giving me what's a centroid? Well, it's the center of a cell. So it's a cell centroid. So if you've got a square, follow my cursor, you've got a square here, the center is going to be somewhere around here. So it's not very well describing it, but yeah, so we're looking for the center, the coordinate of the center of the square. So we have 10 by 10 by 1. So, and it's y, x, z. So we've got y here. So it's going from 950, 850, 750, 650. So the center of the cell is located at the center of this cell. Let's say the very first one is located at 950 and 50 in the x direction. So we're 50 in from the boundary. We're 50 in from the other boundary, and then it's negative 25. So remember, we set the top at 0, the very top boundary at 0, and then the bottom boundary at minus 50. So the center of the cell is going to be minus 25. So it's kind of exactly what we're expecting. So all I'd really want you to do is to kind of see, oh, okay, I see what that's doing. Okay, I see the sort of the results I'm getting with it. So yeah, center of a cell coordinates. You don't have to do it very long, but at least try and do it in your own language a little bit. That's all I'm really like asking for. So let's go over, let's go over breaking up a piece of code. Now I saw some people do some really nice jobs here when I was trying, because what I was trying to do is prompt you to go out and try and break up this and try and understand exactly what's going on here. So what we could do by starting off is just, okay, the code's run already and we know it finishes correctly. So let's just see what typing in ibound does. Oh, okay, so I get an array out, and I can see in this case my array is -1, and then -1 on this side, and then otherwise it's got 1s in. Okay, so this function here, I wonder what this does. Ibounds. So let's look at what the function np.ones, and then it's asking for some it's asking for like x, y, z. So we could just do just asking for some parameters, but we could do 5, 5, 1. Let's see what this. Oh, it's not a 1. Let's see what this gives us. It's not very good. Data type. Oh, I need the data type. Okay, there's not just a default. D type equals np dot int 32. There we go. Okay, so yeah, there we go. It's producing an array of ones. Okay, so I can see what this is doing. And then, so let's just copy that again. Oh, well, we know what iBound's getting. Let's just do this away. So we know that iBound is effectively an array of MP1s of dimensions 10 by 10 by 1 thick. So let's have a look at what this does. So this is indexing. And some people really struggled with this. It's something that we're trying to build up your skills in, because this is actually a really important part of working some of these numerical models. Python's got lots of functions, but in this case, what we're doing is we're using indexing a lot for the next 4 or 5 weeks, because it allows us to go in and ascribe values to individual cells. And that's a really useful thing to do, especially when you want to start to customize things and make it yours, make it unique and custom, because at the end of the day, that's what pays the money, right? People don't just want generic models. They want to know what their aquifer looks like in Somerset or Fukushima or Western Canada. Like, you want to know everything nowadays is as custom as possible. So it's custom solutions. So in this case, yes, we're going in here, and what we're doing is that the index. Let's just take that out for the moment, and that's fine. So let's just run that. Okay, so so you see what I did there was originally it was ascribing this index to -1. I've taken that out and I've rerun that cell. So now iBound is MP1s, and that's overwriting what iBound was, or about 2 minutes ago. And now it's just iBounds equals NumPy array of those dimensions with those number of ones in. And here, on that sort of boundary, or on that index for the for the 0th column, or the first column, we've got an array of ones, so we can ascribe it to a value of 2. And so now if we look at iBound here, so we see the 2's coming in. Okay, so but we can overwrite that. We could change that to a 3. So now we've got 3's on that left-hand side. And so that is that's all of the values in, because it's yeah, long story short, it's layers followed by rows followed by columns. So we've got just the one layer, and we've got 10 rows and 10 columns. So this is all of the layers and all of the rows, and the first column. So it's that left-hand column that's got a value for 3. But we could also do the 5th column. So now let's have a look. See here, yeah, now we've got some 3's coming in there. And then the last column is -1. So that's that column there. We could also do the -3rd column, which is going to give us this one here. Nope, it's that one there. So there we go. So that's a quick introduction to what indexing is doing. And we use indexing, or the first time I ask you a question about indexing is here. What is bottom 1 ... doing? Answering a new cell below. Well, actually, I can't really particularly remember. So this is kind of what I wanted to get to, is how would you actually understand what's going on, and how would you try and figure out that answer? So if we do, okay, so where's this referencing? So this is referencing this stuff here, which is bottom equals bottom 1 ... and that's referencing this here, mp.linspace ztop zbot nlay minus 1. Okay, and then what is nlay plus 1? That's number of layers. Z bottom is, so that's the depth at the bottom, and then that's the top. So we've got some function here. So let's have a look at what np.linspace is. Help np.linspace. Okay, so start, stop, numbers, endpoint. Okay, so these are just these are default values. So endpoint equals true, read step equals false, dtype equals none, return evenly spaced numbers over a specified interval. Okay, so if that's the case, let's just try. Crap. Hang on a minute. Oh. Party time in California. 0, 10. What was the start, stop, numbers? Or I guess we can put in 20 there. So that should give me 20 values in between 0 and 10. Let's just do the default. Ooh. Numbers. Oh, the default is 50. Oh, I see. Oh, so the default's 50 numbers. That's how you get 50 numbers in there. Okay, so nlay plus 1. Oh, okay. So the number of layers is 1. Plus 1 is 2. So if we did 0 to 50. Oh my god. This guy doesn't keep cycling around. Oh, so irritating. 2. Okay. So if we had 0, 50, and nlay equals 1, 2, that gives us a value, or that gives us an array consisting of the numbers 0 and minus 50. So the question was what does bottom 1 squared do to that array? So let's have a look. Bottom 1 dot dot. So it gives us 50. So that's kind of useful. So that's just telling us that the bottom value is an array just consisting of the number 50. So that's all it's really doing, is it's indexing this array that we got out of np.linspace, and it's looking at that and saying, hey, what's actually the second value, because remember Python starts at 0, and the answer to that is 50. But if we had, say, slightly more layers, for example, let's say we had slightly more layers. Let's say we had 3 layers, and that is 0, 25, 50. Okay, let's just call this variable a equals that, and then that. So then we start to pull out minus 25 and minus 50. So, because it's saying start the first to go up in the default steps. So step is default, and then but you start the first, and then otherwise you do all of the rest of them on the default step size. So let's say you could even do like 5, and it's going to start on the first, and it's going to do all of the rest of them up to the end stage. So this is kind of me just showing you. Well, in this case, showing you a bit about bottom and how I would have gone about solving that problem. When someone's asked me, what does this mean? Well, in this case, I would say, okay, so what the function is doing is it's taking the top value, the bottom value, and the number of layers, and 1, and then it's returning a value, and this indexing is returning the first value all the way to the end, which in this case is just 1 value. Now the question is why are we doing that? And if we go to the manual page, so what's the bottom? Okay, So let's have an array at the bottom of elevation for each model cell. Okay, well this makes a bit more sense now, because what we were just looking at is, where was it? Here. So when we had, let's say we had 5 layers, so this is simulating n row and column, is that right? NP lens, no, sorry, not n row and column. Top, bottom, and lay. So the top is 0, so that could be anything, but that's top cell value, and then the bottom cell value is -50. That's meters, by the way. So it's -50 meters down, and it's over 5 cells. So looking at it from using that one dot dot means that we don't take the very first value, so we're always going to get the bottom value of the cell. So the top value is 0, so we ignore that one. That's the top of the very first cell. But the bottom value of that very first cell, which is also the top of the second cell there, is if you split 0, if you split it 5 times from 0 to 50, this is what you're getting at 12.5. So it's 12.5 down, then it's 25 meters down, then it's 37.5 meters down, then it's 50. So it's that. Those are the bottom cell values as we move down through the sort of the layers. So this is what it's getting us. It's giving us an array consisting of the bottom values for each cell. So that's just kind of how the process of mucking around in Jupyter Notebook to try and understand how different functions work that you're presented with, maybe using a bit of Google, and then flicking back to the manual page and reading what they've written in there for the parameter. So yeah, hopefully this might make things make a little bit more sense. And maybe in future you might be when you encounter something a little bit more, what looks like a bit more challenging, like a cell like this size where it's got lots of different things, you can kind of start to figure it out and make your way through it and try and understand it a bit better. So yeah, I'll leave it here. Hopefully if this was useful, let me know. If it wasn't useful, then let me know and tell me what I can do in the next one. All right, so I'll speak to you later.